Hello guys, we have a question in physics and electricity. Now the question reads, figure 7.1 shows a 6.0 volts power supply connected to two resistors which are in parallel. Now we are lucky that we are taught the type of the circuit that we have. And with that information, let's dive into the first question. So the first question is, we want to find the effective resistance. So the effective resistance is same as the combined resistance or the total resistance of the two resistors. So remember, the two resistors are connected in parallel. So we are going to say this one is our resistor 1. Then we have resistor 2. So the formula for a parallel circuit is 1 over RT is equal to 1 over R1 plus 1 over R2. It can be up to R3 or 4, depends with the number of resistors that you have. So 1 over RT is equal to, so resistor 1 is this number here, which is 4, plus resistor 2 is 12. So we have 1 over 4 plus 1 over 12. So we just have to bring in now math. So according to mathematics, we need to find the lowest common denominator for 4 and 12, which is, we know that is 12. Then we are going to divide. The first one, we divide 4 into 12 is 3 times, multiplied by this one here, giving us 3, plus 12 into 12 is 1, multiplied by this one here is 1. So 1 over RT is equal to, the sum of 3 and 1 is 4 over 12. Then we cross multiply because our target, we are solving for RT. So 4 multiplied by RT is 4 RT. 12 times 1 is 12. Then we divide by 4 here by 4. Then the total resistance, which is RT, is equal to 3 ohms. So it simply means that if we combine the two resistances, we are forming one resistance with 3 ohms. So that's what it simply means. Now, if want, we can solve the same answer, but we can just do it directly. We can say RT. This time, we are not going to write this one as a fraction. So say RT is equal to R1. You multiply this time by R2, divided by the sum of R1 and R2. So RT is equal to 4 multiplied by 12 over 4 plus 12. Now 4 times 12 is 48. Divided by 4 plus 12 will give us 16. Then if we divide 16 into 48, will give us 3 ohms. So depends with the one that you are comfortable with. You can use this formula here or this formula here, but the easiest one is this one. Now we move on to question B. Calculate the value of the current, Roman number 1, so in the 4 ohms resistor. So there is a certain amount of current produced by the source. So if we want, we can find the total current produced by the source, since we have the total resistance. So we can say total current, which is the IT, is equal to voltage divided by total resistance. So voltage is given is 3 over, voltage is 6 over the total resistance is 3. So this will give us 2 amps. So the total current produced here is 2 amps. So at this point, we have 2 amps. Now from that 2 amps, we need to find what value from that 2 amps will go in this direction. So that's what the question is. Then the remainder from the 2 will go in this direction. So for a parallel circuit, current divides according to the number of loops that we have here. Now let's go back to the voltage produced. You know that the voltage produced is 6.0, which is 6 volts. So at this point, at the junction, we'll have 6 volts. Now how much will go in this direction? Remember, whenever a circuit is connected in parallel, voltage is equal. So in this direction, we're going to have 6 volts. So is this direction. So since we have voltage and resistance, we can find the amount of current went through resistor 1. So say current, we'll consider this one as the current 1. So say current 1 is equal to voltage divided by resistor 1. So voltage is 6 over resistance for this one is just 4. Then if we divide 4 into 6, it will give us 1.5 amps, which simply means that from the 2 amps that we have, 1.5 will go through resistor 1. So if we subtract 1.5 from 2, we remain with 0.5. So in this direction, we get 0.5 amps. Then for this one is 1.5 amps. Remember, this is current 1. Then this one will be current 2. Then at this point, the two currents will combine to give us the 2 amps that's divided. So that's what it is for current. Now for 0.5, we can also find that number by calculation. So we can say current 2 is equal to total voltage is 6 divided by resistance for this part is 12. And if you divide 6 divided by 12, will give you 0.5 amps. Then to find the total resistance by the addition of the two currents, we can say total current is equal to current 1 plus current 2. Current 1 is 1.5 amps. Current 2 is 0.5 amps. Then if we add, we are getting the same value. So there are so many ways in which you can treat a question like this. So for this one, we have found, so the current for this one is 1.5 amps. Then the current in the battery is same as the total current, which is, we said current is equal to voltage over resistance. Voltage is 6 over 3, giving us 2 amps. We've done this one. Now the question C, this question has to do with some thinking. So question C reads, would the addition of an extra resistance between point A and B in parallel with the original resistance increase, decrease the current in the battery? Explain your answer. Right, so the question is saying, what happens if we are to add the third right? So this simply means that from this point we add another resistance. So let's say this resistance has 1 ohm. So if we are to redo, the total resistance will be 4 times 1 times 12 over 4 plus 1 plus 1 plus 12. So this is 48 over, this one will give us 17. So if you divide the 48 divided by 17, will give you 2.8. So you can see that the total resistance now has reduced from 3 ohms up to 2.8. So say the addition of an extra resistor between A and B would increase the flow of current. So the reason why the flow of current would increase is because the resistance is reducing. So that's it for this video. Thanks for watching.